Okay, everybody, thank you all so much for taking time out of your day to join us here with Incredibuild to talk about turbocharging game production on AWS. My name is Chris Melissinos, and I work in the game developer or the game engine developer services organization here at AWS. I've been at AWS for about 2 years and had an opportunity to work in a variety of different functions that focus on optimizing game development pipelines. So game developers can go ahead and make more art, more games for a bigger, broader global audience more easily than ever before. And I got my start actually in game development more than 2 decades ago when I started working on things like Java and mobile games, all the way to big server infrastructures for companies like Activision and Sega and Sony Online Entertainment. And while back then, game development, going even further back there, typically smaller teams, and you had even earlier than that, kind of the bedroom coders, right? People that were working out of their home to build video games. We don't see as much of that today. Now, you do have some breakout games like Trombone Champ or Vampire Survivors or even Among Us, which use very small teams to create these games that can reach a scaled audience. But more commonly, game development is this collection of technology and art that creates something bigger, broader, and reaches a global audience that becomes more increasingly complex over time. So as we see larger teams building more realistic worlds, more interactive environments, more complex and longer running games and game services, the question that we have as an industry is, how do we go ahead and ease that development, not only due to the complexity and growth that games are experiencing today, but now also doing this with a global development pool where maybe teams are scattered all over the planet, leveraging things like game development in the cloud and cloud-based services to ease that development, to create efficiencies in game development that we just didn't have prior to cloud-focused services. And that's what we're going to dig into today, how Incredibuild, again, can help turbocharge that game production and alleviate some of those pressures that we experience in large-scale global game development for increasingly complex, realistic, and awesome video games. So as we go ahead and jump into this seminar today, I want to remind everybody watching that this is an interactive session. The chat is open. We'll be monitoring throughout the entire course of the seminar. So please bring your questions in as we go forward in the presentation here. We'll answer them as best we can. And then we'll also have a Q&A session at the end of the demonstration here. I should also mention that you want to make sure you stay to the very end of the seminar because Incredibuild has some pretty awesome giveaways for folks that have attended. And so now I would like to go ahead and turn the stage over here to Asaf from Incredibuild, who actually had his start in game development and is now working on leading, tools and development for game developers globally. So Asaf, please take it away.
That's right. Thank you, Chris, and hi, everyone. So I'm running Incredibuild's partnership with AWS. And as Chris said, I started my career as a game developer. Let me start by a question. What do you think is the #1 thing that every game production team in the world doesn't have enough of? They would love to have more of it. They cannot buy it. Pretty sure you guys know it because this is what you're going through. And I'm pretty sure that if we would have this webinar running 2 months ago, only just a few of us will be here on this session because you've been on the crunch. September timeframe is really tough on game production teams. So the one thing that everybody is looking for is time. You can't, unfortunately, store it or share it. And during my career as a game developer, that was really fun. I had a lot of fun, but I also had a lot of stress. And us at Incredibuild talking to game developers, to artists, to DevOps managers, they're all talking to us about time, that they need to get more done within their time, their resources, the hardware that they have, and they just can't make it. They really want to have more time to innovate because this is what it's all about, and they feel bad about not innovating enough, not creating enough because they're under crunch. Developers want to iterate more because the more you iterate your code, or as well as the artists, the quality will go much higher. The DevOps managers want to add more pipeline, more testing. They want to build on every commit, maybe even introduce static code analysis and more workflows, but they don't have enough time, not have enough hardware to support all that. They want to fix those bugs faster, but they don't have the time for it. But guys, the bottom line is they also want to enjoy work. They want to have fun. They want to go home on time. This is all about time. And today in this session, we're not going to tell you how we're going to bend time or stretch time or add more hours to the 24 hours we have, but we can talk about how we're going to help studios, hopefully your studios, to speed up your production, help you to do more, higher quality, deeper, and iterate more, but we don't want to get you into the crunch time. So we're going to talk about Incredibuild, yes, but even if you don't think this is the right technology for you, I hope it gives you some ideas on what you can build on your own or look elsewhere, because I really believe in relying on technology rather than people working very late hours. So this is all about it's time, and this is what we're going to talk about today. So we're going to have a lot of fun. I'm going to show you a few customer stories. Beau is going to show a real life demo. It's not a recorded one, so cross your fingers that everything works as usual. And as Chris said at the end, we have a really nice surprise for you guys. So let's get started. So I'm sure many of you have heard about our product, Incredibuild, because we've been out there for 2 decades, but maybe not a lot about the company itself. So company started by a couple of developers that really hated seeing a slow machine that they're building the code on while they see a lot of idle CPUs in the network, and all that hardware goes to waste, and decided to build a very smart build distribution system that can really utilize all the idle machines in the network and build a supercomputer, almost an HPC that can help developers to speed up their pipeline. So this is how the company started 2 decades ago, and today, fast forward, we're at more than 90% of the public games companies, but a lot of the indie studios using Incredibuild as well. And I'm going to talk about a few of them. We're going to start with some customer stories. Please listen carefully. I'm sure this is going to relate to a lot of the challenges that you guys are going through. And so keep your questions to the end, and let's keep it fun. So first customer I want to present is Proletariat, a very nice studio based out in Boston. They were working on Spellbreak. They actually raised $20 million for it with 2K and other publishers. And then COVID happened. People had to start working from home, really bad network, and all the other family members on the Wi-Fi, VPN got saturated, and they saw how build times get longer and longer, and they're not able to meet the timeline, and definitely not release the game that was supposed to go out in September. So they reached out to us and asked, what can we do? And we said, well, work from home is really not good to use in-studio hardware. Going to Perforce and back through VPC was really terrible. So they onboarded AWS, started using Incredibuild with Spot machines in a way that really allowed their developers to accelerate the workload very nicely. And you can see here the example of cutting down the workload or the build times by half. And this really helped them to get their title released on time. Actually, in September, exactly when they planned, it was very successful. We're not taking any credits for the acquisition by Blizzard a couple of years later, but I'm sure that this game contributed to their success. Another example is not exactly a gaming company, but a very neat one. Wave is a studio that makes a live concerts, virtual concert. So if you want to watch the Weeknd or Justin Bieber that performed through Wave, you just put your VR sets on and just enjoy with the rest of the crowd. These are real-time concerts, and it's really neat. And you can relate that into metaverse and a lot of things they can do. But the problem was that their selection of their game engine tool, or the game engine, Unreal Engine, had a cost of build time. And this created very few iterations, and their Team City was not performing as fast as they wanted because of those fast build times. So they decided to try Incredibuild. They went to the marketplace and really enjoyed the fact that they didn't have to spend much time setting up the environment. Everything happened within minutes and was available to their developers and CI. And you can see the quote at the end, how speed eventually impact fun and impact the product quality. They are very happy, and this is really a neat technology you should all try. Last one, decided to take a small studio. I mean, you can go to our website and see case studies from EA and Epic, but I think that those indie studios relate more to most of the folks here. And Studio 316 is a work for hire in the UK, 5 great guys that helping other studios, and their challenges are different because they have certain SLA, commitment, and projects that they have to deliver on time. One of the challenges they've seen is that they came across a bug that they were not able to reconstruct, and they actually had to build all the version from the end backwards until they see where it breaks. And we're talking about thousands of them that would take at least days. And using Incredibuild, because it runs much faster, within hours they were able to find those bugs and be able to fix that bug that they had in production. So this is another example of how you can speed up not only the production, but also bug fixing and QA.
So Asaf, so what I wanted to also make sure that we hit on here is when we think about, again, modern game development and how game developers, right, we still like to build a lot of the technology and services that we utilize. And in an increasingly competitive environment across many more devices with, as we said, increasingly complex games and product, the type of currencies that we are able to go ahead and utilize to bring that art to the world, right, is not just monetary, it's also in time. So any time that the developer can actually reclaim to just be able to put it into making a better game, adding more features, squashing more bugs, those sorts of things is important. And so that is what Incredibuild enables you to do, right, is to reclaim that time that you normally spend waiting for those builds to happen. So really, really important as you think about your entire development pipeline and how you can go in and reclaim some of that time just to build a better game.
Exactly. And you know what, we've been talking to a UK-based studio. They told us that when they start a day, all the artists rebuild Unreal Engine every day. And that's an hour-and-a-half wait. And guess what? People are not coming to the game production space to slack, right? They want to work. So waiting an hour-and-a-half means that their day is an hour-and-a-half longer at least. So this impact also their work and life balance. So these are workloads that are jamming my computer. If I have a 16-core machine or 32-core machine and I'm building the game, that means that my machine is working on that right now, and there's nothing else I can do unless I have another machine. So this is really, as you said, Chris, impacts also how people enjoy the work and how productive they are. Thank you. So how does it work? So the anatomy of Incredibuild is made of 3 elements. The first one would be the initiator. This is the piece that runs in your computer. You'll find it with Visual Studio. We're already there. You'll find the Unreal Engine already connected to the initiator. So every time you run a build via command line or just the IDE, this will be intercepted by our initiator. Then we have the coordinator that knows what CPUs are idle right now in the studio with the helper agents. So we have those agents. This could be servers, it could be my colleagues' machines, it could be even the secretary machine, if you like. Any machine that you want to make available for Incredibuild will have that helper agent. And then we have on the cloud, Incredibuild Cloud, that know how to handle those workloads on AWS. So as soon as you trigger a build, the coordinator is checking what kind of resources you need and routing you to either the on-prem helpers or the cloud. Now, the secret sauce here is that if I have a 2-hour build and I have some resources here on-prem, some on the cloud, how can I run one monolithic job? So one of the very unique things that Incredibuild does is we know how to break down this into smaller pieces. So imagine Torrent, for example. Torrent is taking small pieces from different users. And this is what Incredibuild does. We break it down to smaller pieces, and we can run some of them on your own machine if you want, some of them on the helper agents on premise. And when we run out of them, we go to the cloud. And on the cloud, Incredibuild manages spot instances to make sure you're not paying too much. They're about 40% cheaper. We take care of spinning them up and down, and also we're taking care of provisioning. This is very important because one developer can work on UE4, somebody else on UE5, and somebody on some other C++ backend on Linux or whatever. So every workload is different. What Incredibuild does, because we run inside your machine, we understand what is it exactly that you need to run that workload elsewhere, and we automatically virtualize all these agents on the fly for what you need. So all in all, when you initiate a build, it just runs faster and distributed and back to your machine. You don't need to call IT, you don't need to do anything manually, it just happens. So this is how Incredibuild works. Let's see an example. This is Lucy. She's working from home today, and she is about to run a build on her Visual Studio. So remember, the first thing we do, we break it down to pieces. Here we have four pieces, but typically we're talking about hundreds. The first thing we do that I didn't mention before is we go into the cache. So Incredibuild just launched recently a build cache feature that is caching those torrent pieces. So we identify here in this case that Lucy actually just added a few features today, but there are others that we know that we just built. She built the other day, and they are being cached, and we don't need to rebuild them. So we're eliminating that part, which could be even 80% of the build. So already here, we're shaving 80% of the workload. We then take the other pieces that are not being cached yet. And in this case, that studio want to use their hardware on premise. So they initiate, the coordinator then finds some resources that are available right now on premise, and then find some resources, spin up some spot instances on the cloud. When everything completes, we then glue it all together into one piece and return it back to Lucy's computer as if she ran it locally. It's so transparent that even if IT installed it on her machine, she doesn't necessarily know how it works and what just happened. She just knows there is this incredible thing that ran it faster. She didn't have to do anything or even understand what cloud is. So all in all, this allowed to reduce her idle time, because during that build, she can actually do other things because we're not utilizing any of her CPUs. She could do many more iterations and add more levels and so on. She was able to deliver it on time. She doesn't have to work extra hours, but also IT will be very happy to hear that it was economical, because for one, we use the build cache. Secondly, we use the on-prem resources that you already own, and then we spin up spot instances just for the remainder that we couldn't handle with the cache or with the on-prem machines. So this is a work from home scenario. Yeah, go ahead, Chris.
Yeah, and I was going to add there for those that may not be as familiar with that, but on-demand spot instances just allow you to spin up servers on demand as you need them for the operations that you need to provide, and then wind down when they're done. So you're only paying for the compute resource utilization for that particular instance. So no more racking up your own hardware, no more having to go ahead and just reserve servers that may just sit idle, costing you money and time. Being able to spin that up on demand and spin it down makes it much more economical than previous models.
One of the caveats with Spot is that it can be taken away in a minute notice. So try to run a 2 hours workload on something that can go at any minute. This is not very practical, but when we break it down to smaller pieces of 2-3 minutes each, it's okay if one goes away and then Incredibuild spin up another one and continues. So this is a much more robust way to use Spot to really be reliable and manage that. One of our largest customers is using thousands of Spot machines for 2 years already with Incredibuild, and they didn't default to on-demand even once. So this is the perfect way to use a well-organized Spot fleet. The other scenario I want to talk about is CI. So, of course, we can speed up all the builds. Every commit triggers a faster build. But the other thing is that it gets to a traffic jam very quickly because you have set amount of runners, but you have many more developers. What if they all submit their code at the same time? It starts to clog up, and it's like you go to you try to park in a parking lot that is full, and you have to wait in your car for somebody to leave. So beyond the slow build, it creates a queue that then slows down the response to developers. So a developer that get a response within hours rather than minutes, they may be over doing something else and context switching, and may take them a day to get back to that code and make that fix. So this adds much more time to your pipeline. So with Incredibuild, you might have as many developers as you want to commit the code to your Jenkins, to your TeamCity, or whatever. Incredibuild command line works with any CI that you use. Remember, we first break it down to the units. We try to see what's cached, and that CI cranking the same code over and over again. So very high chance that the cache is taking a lot of the load. And then eventually we spin up those Spot machines and run it over there. So what we then end up with from a time perspective, each build runs faster because Incredibuild accelerated, and with the build cache, we reduce the queue, so developers get a response much faster. And the DevOps manager will be very happy to know that they can actually run all those workloads that they planned to run before, but didn't have the capacity for it. But from a cost perspective, we reduce a lot of the cost because of the build cache. There are no idle machines. I mean, you can have in your CI very expensive machines. They're always being either overutilized or underutilized, and you end up wasting a lot of money, but not with Incredibuild because we use small Spot machines. And finally, you may run this on a hybrid mode and then use up your local hardware so nothing goes to waste, and that's another savings. So before we go to the demo, I want to summarize that, as you've seen, studios are using this technology and this kind of process to reduce their wait time, increase their throughput, iterations, quality, and really giving their developers some time to do their job and enjoy it and go home on time. So, Beau, over to you.
All righty. Let's see if I do share my screen here. And hopefully that's being shown correctly now. So everybody should be able to see the desktop.
All good.
I'm seeing some nods, so we'll say everything's good. So hello, yes, everybody, I'm Beau. I'm the solutions architect for Incredibuild here in the US. And obviously for today's demo, we're going to be showcasing what Asaf just went through, especially with the cloud provider, to use AWS to burst and be able to create those helpers. And what we're going to be doing today is accelerating an Unreal Engine build from source. So as with that, let's go ahead and get started. And as a reference, what I want to call out is our build initiating machine that we have just to work on vis-a-vis like your development laptop or a VM that you may be using. Our machine has 8 cores. That's all it does. This is a build monitor. We'll be showing this actually in action here in just a little bit. But the main thing we want to call out here is we have eight cores. And if I show you what the build time was initially, right, we're talking about saving time. We had 6,000 files that needed to be crunched, if you will. And it took 2 hours and 31 minutes and some change to do it on this particular machine. The other thing that we can kind of call out here too is if you see right here where it says tasks of 2,991 and then 8 tasks running, what that means is at any given time for those tasks, we're consuming each one of those available cores. But in the meantime, I still have almost 3,000 processes that still need to get done, right? So it's a good indicator that we need to be able to accelerate that. So with that, let's show you how we do it. First thing we're going to do is Asaf had mentioned several different components, an initiator and the helper. Everything for Incredibuild is managed centrally. And what we have here is the coordinator. We're going to go ahead and log in. And it's going to hit a main landing page, which happens to be aptly named Agent List. But really, it's a high-level overview of what your environment is and what it's doing currently. So I can see that I have some machines online, how many cores may be being utilized, or how many builds are actually underway. I can see things such as licensing and how machines may be set up, whether they're helpers or the initiators. All that's nice and good for a quick screenshot, but the main thing we want to be able to call out here is as you build out your compute grid, that's going to be listed here. So as we begin to add in the Incredibuild cloud components, we're going to see this compute grid grow live. Now, part of this is we can drill down and begin to see information about the individual machines, the helpers or the initiator, things such as disk space and memory, and more so things like we might be interested in is the CPU information type. So this is an 8275 Intel. But what we can do is begin to change settings or what we might need to do for operational considerations on that build, where maybe I need to come down and change the build priority, where this machine, I want to make sure it gets selected early, or we want to begin to shape things where I can group like CPUs or machines that may be not as powerful that we just want to use for small test builds. I can get down here and drill in and even get very granular by going into advanced configurations, even to change things that may have an impact to those machines running our build. But part of the whole thing of centrally managed is the fact that I can also do this all at once against all the machines in my grid. So kind of the same things we just walked through, or to change a build group or log levels that we might want to do on these individual machines. All of this is going to be centrally managed. And as we go along, as the demo gremlins will show up here, there we go, get into our settings. We march back up and, again, I can get down into the agents where I can help control how my build's going to be to make sure that the resources are available, to have certain disk space or CPU available count. I can come in and even do things such as high availability and set up a backup coordinator so we can always keep things up and running for the build processes. But for today's sake, what we're really interested in here is the cloud and how we're going to onboard it. So if I get here, what we're going to do is go ahead and say scale to cloud, and this is going to be a very straightforward and easy to consume process for you. We're going to say scale, and what we're going to do is sign into the service. Now, normally, if you don't have a user, it's very easy to create one, but we already have one obviously set up, so we're just going to say log in. The very next thing that the coordinator and the service is going to prompt us for is to say choose your cloud provider. So obviously, we're with AWS. Now, as with anything, we want to be secure. We want to have things set up for roles. So you have to have role ARN and external ID. All of this is in our documentation. But to be honest, if you're used to working in AWS, the cloud, the normal setup that you're used to doing with any sort of IAM policy is very straightforward, where you're going to set those capabilities and permission settings. So we'll go ahead and type in our role and our external ID for the third party. And that's just going to authenticate and make sure we're all set to go. And then we actually start for the cloud setting. Now, this particular demo environment does happen to be running out of London. However, everything we're going to have is very simple, easy to consume dropdown. So if you had to run it in US East 1 or US West 2 or whatever you might need to do there, you just select that, very straightforward. The next thing that we're obviously concerned about is the network. Now, 99% of our customers are going to already have private networks set up through their VPCs. It's very easy to drop down once that role has access into it. we could come down here and select the VPC that's running the 10 network, and then pick which subnets we might actually want those individual helping instances to be run on. And then, of course, we always want to be security minded. So you would set up your security groups with ingress, egress, and then the port settings that we may need to have. But for this, we could just pick which one that might be set up for us. The other thing we can also do, though, that's for private, for people who already have things set up in the VPC. But you already have a public facing internet that you want to use. And you can still do the same thing of use your existing network, just like we did with the private, or you can let Incredibuild create everything for you. So it would create the VPC, the subnets for you, and the security groups all on the fly. So for today's demo, that's exactly what we're going to be doing. We're just going to let Incredibuild do this for us. The next thing is we're going to set resource management up. This is where you're going to come in and actually set the instant types of machines you want and the timeout values. And then also what we're going to be concerned about is Asaf mentioned that we use spot instances to take advantage and be very cost efficient, right? So the cloud providers have this excess capacity. They would like for you to use it. They want to be able to offer it to you. However, if there's contention, they will reserve the right to pull those back. So as part of that, we do recommend as a best practice for spot instances. And we're going to show you how we fall back here in just a moment. But this is where you can select to use that or use on demand if you so choose. Now with the virtual machine types, this is all fairly straightforward. This one happens to be saying we're going to go ahead and set some C5 16 core machines to be our primary cloud instances when they deploy. But again, it's a simple drop down of what you may need for your operational considerations. Maybe you want 48 cores, 68 cores, or let's even say you want some monstrous machines. Either way, this is where you would come select that. Now disk types, we're going to leave it SSDs. Because basically when you do linking, that's a high input output, right? So you have high IO, that's disk intensive. We want to make sure that we can go fast there, so we'll leave that. The timeout is something that's important. We want to be good stewards of the environment. So we will spin up and run machines in a pool. And down here, we show that we have 7 that we want to start with. So we will start and initiate 7 machines to run. However, they don't need to just run all of the time, especially if you're not using builds, or maybe you want to schedule this in the evening to spin up to do full builds. So, Q&A and testing can be done in the morning, and then the developers know what they need to work on. But we don't want to just leave those running. So you have a timeout value here that would shut them down, in this case, a little after 8 minutes. But what we were interested in here is how big to set our initial size. And we want to say we want to have 7 machines at the 16 cores, which gives us 112 cores. But what I want to be able to do here is have a little bit of fun. We're going to say max number of cores. Let's go ahead and change this and up it to 240. So what will happen is when Incredibuild kicks off and deploys these instances to make them ready, we will start that pool size of 7. However, we will allow it to expand and grow based on what those needs are that we saw earlier about ready tasks and active tasks, and allow it to deploy more on our behalf and automate and orchestrate all that under the covers for you, so you don't have to do that. Last thing that we talked about earlier with the spot instances was how do you control if the cloud provider needs to deallocate that? We can always allow failback to on-demand machines, but at the end of the day, what we really want to be able to do is intercept that API call saying it's going to deallocate and immediately start looking for additional machines. So obviously we can let Incredibuild do that and find the next fallback machine. But for operational considerations, should you need to decide that you want to control this for your needs, I can come in and begin to change and shape what I want. So if I said I want some M4s and M5s and maybe a C5A, what will happen is if we have to deallocate, we will immediately look to start another instance on your behalf of that C5 side. If we're not able to find it, we will roll through this list and go from M4s to M5s, etc. But again, for today, let's keep things nice and simple and straightforward. We're just going to let Incredibuild find a fallback machine if it has to deallocate. Last thing is advance notice, right? We're going to give you some administrative emails or alerts or something along those lines. If you needed to change port numbers, you can do this. But more importantly, often in the DevOps consideration, or just how as companies grow, they need to look at chargebacks. They need to understand how their systems are tagged and what they're being used for. You can add tags to these machines so you can easily track and follow them. Last part is a summary report, just kind of telling you everything that we chose. And then we're going to enable. So a fairly straightforward, simple process to consume and quickly set your settings the way you need to. And of course, at any given time, if you need to change this, you can always come back in and change those types or adjust VPCs, things of that nature as your environment grows. So we're going to go ahead and click enable. Now that's going to take it just a few minutes because in the background, we are setting up the VPC. We're setting up that subnet that we talked about in the security groups. And looks like we just had something, Israel, the first demo gremlin showed up. And it looks like it didn't want that other one. So as always, everybody loves this part when you get a demo gremlin real time. But being simple to do, let's go back here and we'll make sure that we check that summary. We're going to leave that. We're going to leave this to set. That's all good. Find our fallback machines. And now let's try to enable. There we go. So as always, demo gremlins are fun, but you saw how quickly we can immediately recover and go back and change what we need to. But underneath the covers right now, the activation is completed and we deploying the VPC, the subnets, and the security groups for this. And what's going to happen is that spinning those machines up, we're going to come back over to, remember we talked about our grid. As these machines come online, we're going to see them start to populate here. So again, that takes about 1.5 minutes to spin these machines up. Just as a quick check, did anybody have any questions in the chat channel that we needed to capture real quick? Not seeing head shake from Chris or Asaf. So what we'll do is, one thing I will call out is oftentimes we get asked by customers, oh, I'm sorry.
Actually, we did have one question. Not sure if this is exactly the right place for it, but is the build cache stored on AWS or does the coordinator need to sync to the remote helper at each job? Was the question that came in.
Okay, perfect question. We'll answer that, and we can always bring that back into more in depth later. Be happy to do that. But the build cache itself is set on the initiator. And on the helpers, there's also a helper cache. So as files are being moved back and forth for processing, if it turns out that the helper already has that file, we're not going to request to have it sent over from the initiator again. But the build cache that Asaf was referencing earlier actually resides on the initiator machine, the one that's actually doing the build, so that as it gets everything back and it packages up and does all this linking, it has that in a cache file that then it can check on the next build if it needs to accelerate or not. So perfect question. And one last thing I will say is one question we get often on, does Incredibuild run on your own VPC or is it SaaS? The orchestration is a service that connects with the coordinator, but everything that you see here running here, all these cloud instances that are coming online, these 7 machines in the pool that we specified earlier, all of those are running in your VPC. It's nothing that's running in ours. It's not hosted on our side with traffic going back and forth. This is all self-contained in your environment.
And I want to add, this is very important for those of you that want to keep your code secure, because this is really still in your hands and you can secure it as much as you want it. We don't get access to any of your code.
Good call out. From a security aspect, Asaf, as mentioned, is we're not in on this. We're just providing and creating your compute grid. And as the files and things are moving around, that's still under your control. We don't ever see or look into that, and it never comes back to us in any shape or form. So what you may have noticed as we're moving along and just being cognizant of time, you'll notice that what I did now is I've clicked off the Unreal Engine source build. Now this will take about 2 minutes under the covers to go ahead and do a clean. But as this goes through its clean, and then it's going to integrate and it's going to start accelerating these jobs out, what will happen is we will see these cloud instances come online. So the initiator will turn on and it'll be an amberish color to say, I'm doing a build. It's going to talk to the coordinator and say, I need additional cores to be able to run my build. What do you have available? And the coordinator is going to hand back all of these cloud instances and say, here you are. So when this kicks off, what should end up happening is we should see the 112 cores from the cloud instances here, and then we'll add in the 8 from our initiator. So when it does kick off, we're going to see this jump up to 120 busy cores. We'll also open up the build monitor here in just a moment when it starts. One thing I wanted to reiterate is we are easily consumable in your fashion, what you need. We're agnostic. So if you have a command line orientation that you'd like, or you want to be integrated with Visual Studio, we have a native plugin there. Unreal Engine, we already a native integrated where Unreal Engine, if it detects Incredibuild, will automatically take advantage of it and consume, just as you're seeing here. And then also just to reiterate something that Asaf said is we're agnostic to your pipeline. We can be plugged into your pipeline however you may need for your job using those command line capabilities, but we're agnostic to whether you're Jenkins, your Team City, Circle CI, whatever it may be, we can simply plug in there. So here we are running, and you'll see that the cloud instances have come online. And then what we'll do for the last thing here is we'll discuss very quickly the build monitor. Now, this was exactly what you saw earlier when I showed you the 8 core. The difference is now it shows I have 120. Now, one thing I'm going to call out here as we're walking through this, remember we told Incredibuild that we can burst and allow it to go up to 240. So what should happen here is it's going to recognize it can consume more cores from our mapping here, those system graphs that we talked about earlier. I have 120 tasks running currently on those CPUs. I have 896 that are still waiting to be distributed, and we're going to recognize that we can use some more. So on the back end, Incredibuild Cloud is going to spin up to that number of cores that we set earlier. Although I just realized with the demo gremlin, we didn't set that part. So either way, that would actually be what happened. So love demo gremlins when they get in on you. But the last thing we'll show here is on the build monitor. We have a way that you can graphically see your build. Each one of these bars is a task, and things such as green are tasks that have completed successfully. Purple are actually ones that are obviously in play. You can see them running. This cyan blue color represents a linking, which happens on the initiator only because it's, as we mentioned before, it's a high IO intensive process. So we need fast disks there. But as I scroll down, you can see all these tasks have been distributed out to the cloud helpers, which you can see corresponding underneath the covers here that they're running and processing. Last thing we will show here is that you can also change some of the systems graphs based on what you may need to see. So if there were things that you wanted to watch, you can easily turn these on and turn them off to help you understand how your build is running. In this case, I'm just curious about what the memory is doing in that processing time. But all of this stuff allows you to begin to see what's happening with your build. These build monitors can also be saved off and then shared with other developers, or if you actually end up interacting with Incredibuild to help shape or look at how things are running, we would ask to be able to see these as well. So now what we'll do is we're going to start this build monitor that I saved off, because what we're going to do is, for the sake of time, if I let this run the full time, it's going to take about 20 minutes.
Hey, Beau, while since you have the build monitor up, a question came in. Is the build monitor thing part of the Unreal build tools, or is this part of Incredibuild's tools?
Great question. It's actually part of Incredibuild. It is something that you get as part of our setup for creating your compute grid with those 3 elements that we talked about. The build monitor comes as part of the Incredibuild software, so that you'll always be able to come in and replay, just like we're doing right here. I can come back and see how I brought the machines on. And since we did have that one little demo gremlin, what I'm going to do is come down to about the minute 30, if I remember correctly. This started with the 120 cores, as you can see through here. But right about this 140 mark, it realized that it needed some more cores, and it spun that up automatically. But again, this is the power of the visualization, as you can come through and see these things and know how your build was running, or be able to understand, like, maybe there's some dependencies that I could change, or I can see exactly what's going on. And if we have a warning or an alert, we can take you directly there through this tool, such as we can look at the outputs and see exactly what was going on that you would see normally during a console, but we will highlight those other warnings or errors. But to close this off, what we want to show you is when we use the power of the Incredibuild Cloud, we still had that same 6,000 files that had to be built, but now utilizing all the cloud cores, we took it down to 20 minutes. So 20 minutes and 18 seconds. So that's a 7.5 times acceleration rate, or you can say you reduced your build by 86%. And with that, that is the demo. I appreciate your time and apologize for the little hiccups, but it does show how fast you can easily reset things and change your configurations with Incredibuild. So thank you.
That was fantastic. Before we jump to the back part of the presentation here, just one quick question about the build test. So how are the build tests broken into different components? Was a question I thought probably be relevant right on the back of the live demo here.
Make sure I understood the question in Israel. This may be something that we're saying. Sorry, could you repeat the question? I'm looking for it now.
Sure. The question came in, how are the build tasks broken into different components? So I'm not sure if that is descriptive enough. So if the person who posts that question would like to submit a second question with a bit more
Chris,
information.
I can try to pick it up.
Very good.
Incredibuild has its special algorithms to identify dependencies. And we also have the capabilities to do predictions. So the developer might have defined two modules as dependent, but we have the prediction that we can actually break it down to separate paths, and they are not dependent. So we have these capabilities embedded within Incredibuild to know how to do it. So we don't need any instructions from the developers.
Okay, perfect. Thanks, Asaf. It looks like there was another one in here as well. It says when connecting to Unreal Engine, do the servers assist in GPU/CPU processing with real time? For CPU, yes, that is all real time, as you just saw in the demo, how we expanded out on the fly to the AWS instances that we created, or as Asaf mentioned very early on, if you had additional machines, a desktop under your desk and your laptop, all of that will be done in real time and farmed out in real time. Currently, it is CPU only. There's looking at the possibility to expand in GPUs down the road. Are there any plans to support OS X? Yes, there are plans to support Mac. That is underway right now. I don't have a timeline from product, but that is a high priority to us. So I would look to that to be in 2023, because we do know there are projects and game houses that are using Mac and Xcode. So that is already in play and currently being actively developed.
Beau, if you can stop the sharing, just to swap back. Thank you.
Yeah, and if you have any additional questions, please go ahead and add them to the Q&A, and we'll go ahead and address those last open questions. Well, right now, because here's the Q&A slide. So how about that? All right. So we had one in here that said this demo focused primarily on increasing cores and bandwidth for a single build to decrease the build time for that single build. Are there also other methods for dealing with load balancing multiple builds in parallel by priority, number of files, etc.? Or would a large build starve out the system for other builds that start later?
I'm happy to take that.
Please.
There is a way that you could ultimately, if you consumed all the cores that were available in your system, yes, then that build would obviously consume everything that was available. But there are ways that we showed early on inside the coordinator where I was showing how you could begin to shape your builds with the build priority or build groups, where I can begin to shape and say, I want these machines to be available to like this development group to run, so that you don't run the risk of just saying one person gets to starve out your entire compute grid. We do offer the capability to run multiple builds. It is a feature functionality that you can add. So where they would be able to run multiple builds at once, and then that would farm out. And then you would shape that data, or excuse me, shape those jobs through the build priorities and the build groups. And there are some things that I know product is working on as far as how priorities may be handled in the future, or how you may be able to shape that even more granularly. So those are things that engineering is working on. But you do have the capability now today to build in parallel and not starve yourself out.
Awesome. Okay, next question. Did you consider integrating Incredibuild into UE5 cooking process?
Again, that is being looked at always, but currently right now, cooking is obviously set for the individual platform that it's building for. We will help accelerate the compilation components, but then the cooking right now is still just something that's separate that we're not distributing and accelerating at this point in time.
Okay. Is there any overlap between Incredibuild and Unreal's DDC and also the new cloud DDC that UE 5.1 supports?
I'm going to yield that back to Asaf or Israel, who may have some additional information, especially for cloud DDC, but I'm not sure off the top of my head.
Yeah, me neither. I'm sorry about that.
No worries. Whoever posted that, you can reach out to Incredibuild so we can follow up with an answer for you. So also, to be clear, this works with both Unreal 4 and 5?
Correct. Both Unreal 4 and 5.
Excellent. Okay, and then the final question that came in, can Incredibuild coordinate unit integration tests using the same fleet?
Yes, we do support unit tests. Those are obviously very unique use cases because each shop of how they're setting up their unit tests or what they may be doing underneath the covers is going to be different. It's not just as straightforward like we showed today. Here's an Unreal build or an open CV or something you may be doing just to package up your binaries or compile libraries, which is a very straightforward process to accelerate and distribute. With unit tests, there are probably a little bit more minutia in there. We do have the capability. It's just those types of things that you would have to test, but you would use all the same underlying components and the same initiators and the coordinator and everything else as far as what you saw today.
And I will add also that it's easier for Incredibuild to distribute or break it down to many more pieces. So you might find in our website a case study that talk about reduction from 20 hours down, from 11 hours down to 20 minutes of unit testing on the cloud. So that really changed the whole methodology of how they test and return the feedback back to developers as near real time as possible.
By the way, there was a question about TeamCity, and this customer used TeamCity as part of his CI/CD and unit test 20 hours to 11 minutes.
Excellent. All right. I think those are all the questions that we had live from the attendees today. So, I mean, really great, gang, this live demo. One of the things that we talked about was make sure this was a live demo and not something that was pre-recorded, right? And you can just see how easy it was to actually go ahead and spin up the resources that were required to go ahead and decrease the build time for, a particular game or particular workload, so you can get to building your game faster and reclaim that time. Incredibuild is available on AWS Marketplace and really simple to head on over there, give it a try, very quick. You connect as it says right here, connect your on-prem and cloud tools to Incredibuild within 10 minutes from engaging there in the marketplace. And you can take a 30-day free trial because it's free. So yeah, make sure you head on over to the AWS Marketplace, check out Incredibuild, go ahead and give it a try. 10 minutes to get you up and started and 30-day free trial. Okay, so we have two quick offers here. The first one is that for everybody that joined today, for the first 100 people that were able to join and register and attend today, will receive a $30 Grubhub credit, and that will be sent to you in email in the next few days. So incredible. Thank you for doing that for everybody that attended here today. And they also have an offer for companies that are ready to go ahead and try it in Incredibuild and want to go ahead and plan their proof of concept for the first 20 studios that reach out, that are studios with at least 5 Unreal Engine developers ready to test out Incredibuild. Incredibuild will be giving away a Nintendo Switch Lite to the first 20 studios that meet those requirements, ready to try Incredibuild and sign up today. So stay tuned for follow-up email with that information to book your meeting. So, again, when we take a look at the, incredible partners like Incredibuild, right? It's also hard to not use the word incredible and then have it sound like it's pre-canned in our marketing messaging, right? But partners like Incredibuild that enable game developers to harness the power of not just on-prem, but on-demand cloud infrastructure to drastically decrease the amount of time it takes for globally dispersed and larger teams to just get to building their games working against the same build. Super powerful technology, really incredible partner of ours. And hopefully this seminar will give you the all the reason you need to try out Incredibuild and see how it can positively impact your workflows in your business today. So I want to give thanks to the incredible team for taking the time and putting together this demo and for allowing us to participate in their seminar as well.